Hello, my name is Tony Chan, reporting for TelecomTV. Today with me is Uri Elzur, who is the Director of SDN Systems Architecture for Intel. Welcome to TelecomTV. What is Intel's role in the SDN and NFV ecosystem?
Thank you, Tony, for the question. Actually, that's a very good question. We view SDN and network function virtualization. First of all, they are associated and affiliated with each other. NFV represents a specific need and desire by one industry, the telco industry, to go innovate, replace their infrastructure, make it more cloud-like so that they could move the business faster, offer services that allow them to have a larger share of the pie and have a more healthy margin. And in order to do that, they are going to use multiple technologies, SDN is included. Actually, as was explained in the talk delivered in this event earlier this morning, we actually are working to develop a holistic view of this whole thing. And we really think about the infrastructure as a whole. And that's why we call it software-defined infrastructure rather than only software-defined network. The network is really a critical and essential component in the ability to deliver that kind of agility and innovation and business advantages as sought by the telco industry. So what is it and what does Intel do in that space? With the virtualization of the infrastructure, lots of the action is really moving to the edge. And for us, the edge represents many servers. As you know, as everybody knows, we are adding more and more cores, which really means that a single physical unit of compute attracts more and more workloads. As it attracts more and more workload, you need to think about what do I do with that, what kind of workload is it, and how am I going to make my platform ready to handle that. Specifically for NFV, it could be telecom-related workload. That workload has very specific requirements that are not always exactly what you find in cloud. Actually, in many cases, they are more stringent than that. They are really sensitive to performance. They would like to see appropriate levels of quality of service. They would like to see as little delay as possible. They would like to see jitter under control, which a normal cloud user don't necessarily get to see, but all of those advantages are related to them too. So when we think about this whole issue of software-defined infrastructure, we say, wait, we would like to do few things in our platforms in order to enable this really important evolution, to some people revolution, of the infrastructure. We would like to make sure our platforms have the ability to run extremely efficient, exactly the way we are moving our platform following Moore's law for so long and showing so much performance improvement. We would like to do the same for network workloads too. We would like to do the same for storage as well. When you talk about compute, network, storage, security, energy, management model, all taken together, that's what I'm calling SDI. So I'm sure you're going to have more questions. We can go deeper into how we improve our platform, but just to leave you with few ideas, improve the ability to deal with network by making the virtual switch, the vSwitch, much more capable, much more robust. Allow the platform to play in the same kind of language, the same kind of APIs that are really used at the high level. At the high level, in order to enable this SDI, you need to talk policies. We are actually bringing the platform to be able to play along so the platform understands policies, can enforce policy, can allow you tighter bin packing, lower cost, again, a benefit for your business.
Okay, so there's this software mentioned in SDN or SDI, as you mentioned. Is Intel actually getting into software as well?
That's a wonderful question. Intel is mainly maintaining its role in the industry as providing building blocks. It doesn't mean, and if you follow the different press releases we are doing, is that whenever there is a need and request by customers, we are definitely stepping into new areas. We just recently announced a big collaboration with Cloudera on big data as an example. But we are obviously still providing the same building blocks as we used to do before. One way to think about the change is to say, wait, yesterday when you gave me a server or a NIC or a chipset, I was expecting you to also give me the software for that. I mean, I didn't expect you to say, hey, here's the silicon, take it and write a little driver for me. You were thinking, I expect these guys to give me the basic building blocks and then I could add my innovation on top. That was the old familiar model of here's a server, here's an operating system. On top of the operating system, you and I can develop our differentiating applications. Well, the definition of that operating system, as well as the definition of the server, is changing in front of our own very eyes. So what happens is, what used to be the server is a scale-out model. It's multiple machines, multiple virtual machines, multiple containers, all in a larger distributed infrastructure. The software changes as well. So in order to deliver what I call this driver, now I need to actually work with vSwitch projects like Open vSwitch. I need to work with SDN projects like Open Daylight. I need to work with cloud operating system like OpenStack. So at the end of the day, I really give you the basic building blocks that allow you to do the innovation, because you don't want to burden yourself with understanding the low-level details of the infrastructure. So in that way, I would say, yes, we are going into software, but this is really infrastructure. This is, call it middleware. This is enabling that transition to happen. We are definitely maintaining our existing business model as we used to have before.
Okay. So from a vendor's perspective, how are you approaching your potential customers, like service providers, and kind of educating them on how to implement SDN? Like, where do you think they should start if they're looking to do SDN?
So there are many different types of vendors out there, and I think what we're doing is starting from events like this. We are participating in events. We are trying to help have a bi-directional interaction with end users, as well with our traditional partners in the industry, as well with our traditional OEM partners or TAM partners that deliver that kind of technology to the end user. We are participating in standard activities, so working inside the vendor community, making sure that all of those technologies are open and standardized. And similar to the changes in business that you find in the server, for instance, we are all witnessing the rise of mega scale, warehouse scale data center, which give rise to tier 1 cloud service providers. So we work with these guys. Some other folks are saying, I like this model. Can I have my own copy of that? And they would go work with ODMs. So we would work with the ODMs. So following the needs of the business.
Right. Do you think SDN is more applicable in the data center rather than like on the wide area network? Or do you think it's kind of just hardware and software that is applicable everywhere?
What I'm actually doing internally is I'm trying to shy away from the word SDN these days, because like any other word, it becomes overused, not to say abused, and it may mean different things for different people. And so in order to make sure everybody gets the right message, we're saying, wait, this is what SDN NFV has to do with a server, and you're aware of the fact that we play some significant role over there. Let me tell you what SDN may also do for your data center. Oh, there is also a role it plays in a wider network. Now, all of those may follow similar trajectories on different timelines, different set of vendors, different needs technically as well as business. And so we actually are organized such that we could address all of those. But the technology means different things in different areas. In answer to your earlier question, I really covered some of what needs to happen for the server sitting in a data center trying to do that. If we are thinking about the role a server can play in wider network, and in parentheses, don't forget that we also offer switching products that could be used as the infrastructure in a data center. But let's talk, just to have two extreme, let's talk about wider network. You see technologies that are now becoming possible that before were very hard to do as we separate the control plane from the data plane. Now I could say, I really need this routing solution. I would like to take, for example, MPLS, which is a very common technology used in the wider network. I'd like to terminate it right here on this general purpose box that used to be a server. Yes, it's still a server. It's now doing a networking role. And I'd like to inject something into that MPLS environment. I would like to scale my evolved packet core and start chopping it down into some virtual machines or some containers, run it on specific servers, and get the best performance. And 5 seconds later, I'd like to run something else over there. And so we are working with all of the relevant players in this area. We are running multiple POCs in order to understand the issues together, help the industry move forward. And so the short answer is we are playing in all of those fronts. The role we are playing in each of those areas is different based on the needs.
Okay. So as one of the, well, as the world's kind of leading chip maker, I speak to a lot of networking equipment vendors, and there's always a debate on whether or not you have to develop chips, specifically to address routing, computations,
Right.
and then there's the kind of merchant silicon that.
Sure.
So where do you guys come into this discussion?
That's a wonderful question. I really thank you for giving me the opportunity to answer a question like that. As an example, a slide I was showing earlier this morning was showing really the remarkable growth in performance that we are seeing on a general purpose CPU running network functions. Specifically, we were showing 220 gigabits on a dual core, on a dual socket 16 core Xeon machine. This really represents a number like 30 million packets on a core. These are huge numbers. And we are talking specifically about the smallest packet, which obviously poses the largest challenge for you, because every packet you have to understand, what's my context for that? What do I need to do for that? And then you have to go do the processing. The larger the packet, more time you get to do that. So we are specifically using this kind of a benchmark of 64-byte packets, layer 3 forwarding, in order to show the really remarkable capabilities. And we are using technologies to enhance what we call the data path, where you process the packets. Specifically, we have a technology called DPDK, Data Path Development Kit, and there are multiple versions of that, as I touched on. So what you see is that as the number of cores increase, as we optimize packet processing to a general purpose architecture, as we are trying to make sure that the general purpose architecture is really a good fit for SDI. So it's not just for compute, because you cannot stay on compute. The infrastructure, the demands of the application don't really distinguish between, oh, this is just compute, do it over there. No, this is just networking. What they would like to do is have all of that run in one place, use one building block so they get the lowest cost and best return to the business. Where is the line between what you could do on general purpose to a specific ASIC? There's always going to be a line. If you are building a specific ASIC to do specific role, you're going to be always overperforming. But what the exercise we did on compute shows is that when you're doing a very decent job for more than 80% of the needs, people flock to that, they use that, it solves the problem, and they are always going to have specific equipment around it.
Okay. Lastly,
Sure.
one of the debates or discussions in the industry right now regarding network functions and virtualization is the fact that the underlying hardware infrastructure are sometimes deemed not quite carrier grade yet. So as the kind of designer or promoter of that hardware stack, where do you think the industry needs to go to develop this kind of reliability or scalability that is required?
So, if I may, I would turn this question a little bit on its head. There are specific requirements that are needed from the hardware. Many times in telco with the standards that have, and since they're also under regulation, the standards have evolved over time. They are dealing with things like NEBs. They need to have specific requirements for reliability, failover, issues like fire should start here. I don't it doesn't mean that the whole world goes dark or something like that. But why I'm saying let's turn the question a little bit on its head is that we need to be careful between what is needed at the hardware, what is needed at the physical hardware system, and what's needed in the software. And these are three distinct areas. The hardware, in many, many cases, is really not your major concern these days. Even though we are packing more and more transistors into one device, those are very reliable machines. And actually, originally in the virtualization days, people say, oh, what do you mean? I'm going to move all of this into a single die? And people are very comfortable with that. At the box level, at the hardware level, yes, there are things that we need to do, and the industry has lots of experience with that. Multiple power supply, multiple fans, put different boxes that are part of the same application on different power grids. We have solutions for that. I think that the first area, it doesn't mean that there's no work in all of those areas, and we are definitely addressing that. And we have specific SKUs, by the way, that offer more HA features, that offer more RAS features. So we do already handle that, and we are in constant interaction, and we are responsive to the needs. I think with SDN and NFV, there is actually quite a significant challenge in matching the software to this crazy dynamic infrastructure that telco specifically, this is not their heritage. This is not where they are coming from. I'm used to have this box, and I have my EMS manage that box, and that box is not changing in the next 5 years, and life is wonderful. Now you want more bandwidth for firewall? Oh, let me spin up a few more VMs. EMS, OSS, BSS need to comprehend that. That is going to take time till we really reap all the benefits.
Right. Great. Thank you very much for joining us today.